good health. I mean,
Yeah. Um,
yes, we can see your presentation right now.
all right. Very good. So my name is Moriba Jah. I'm an associate professor in aerospace engineering and engineering mechanics at the University of Texas at Austin. And my main reason for chatting with you folks today is to see if I can help motivate ideas for mixed reality, extended reality, augmented reality, virtual reality that can help enhance or enable very critical decision-making processes. So I'm going to not talk about the theme of this conference. What I'm going to do is show you some problems so that hopefully people can think about, how to solve some of these things with augmented virtual reality and these sorts of things. All right. So we have these things called satellites, and these things provide a variety of services and capabilities that we all depend upon on a daily basis. Everything from communication, position, navigation, timing, weather warnings, the ability to sense things that the human eye cannot see, measuring things in different wavelengths and frequencies, supporting agriculture, where to plant things, where not to plant things, hydrology, education, banking services, financial transactions. Uh, all of these things are space-based capabilities. So, question is, how would we feel and what would we do if these disappeared? And I can tell you that none of these services and capabilities that I just spoke to you of are guaranteed to work. These things are exposed to the elements of the space environment and could suffer a variety of different threats and hazards in space. In fact, we have an assumed space object population, and I say assumed because this is coming from NASA's Orbital Debris Program Office at the Johnson Space Center in Houston, and we hypothesize relatively small object sizes down to about 1 millimeter in size all the way to the space station, that there's about 500,000 of these anthropogenic or human derived, human-made objects in space. Things as small as 1 millimeter in size could cause damage to a working satellite providing any of the services I just spoke to you of if the relative speed is high enough. Bullets are very small, but bullets can do a lot of damage because they have a lot of kinetic energy, very similar to very small pieces of debris. We can't track things as small as 1 millimeter. We can usually track things as small as a cell phone. So if we look at the population of anthropogenic space objects ranging in size from, say, 10 centimeters to the space station, we're looking at about 26,000 objects, of which about 3,000 are things that work, that provide these services that I spoke about, and everything else is garbage. So this is a bad situation. Here's a video from AGI that just shows you over the years since Sputnik launched in 1957, kind of how this population has been growing. The dots are not to size, they're not to scale, they're just showing notional location of these things. And you can see that, we humans have done what humans do best, which is basically pollute environments. So there's a wide variety of objects that we've been launching, again, since 1957 all the way to now. Next here, so what happens when two objects meet at the same place at the same time, but their speed is not similar? Okay, so same place, same time, speed is very different. Bad things happen. Collisions end up breaking up objects into many smaller objects, and these now become a debris field that we have to find ways to navigate. So let's see if I can get this thing to work. Sometimes there's a little bit of an issue. Let's see. Well, we'll go back here. Let's see. Here we go. So in 2009, a working satellite, Iridium, collided with a dead satellite, Cosmos. These things met at the same place at the same time. And this is clearly a simulation, but you know, qualitatively, you can picture this debris cloud that's a consequence of this collision spreading around the globe. And many of these objects are then untrackable because they're too small, but now these are like random bullets in orbit that we hope working satellites do not run into. Okay, so this is also bad. We've developed a multi-sourced database called Astrograph, which is what you're seeing here. But if I have time, I'll actually show you the physical website for this. Within the next few years, several companies are planning to launch many satellites, over 10,000 satellites within the next 5 years. If these circles, which are a number of satellites as a function of altitude, if these were uniformly dispersed, it would be less of a problem because everybody would be operating in a different altitude. But that's not the case. The fact that any of these circles overlap means that it's a shared environment that needs to be managed. And we don't have space traffic rules. Basically, it's like the Wild West in space. It's a poorly monitored domain of activity. We don't have a globally shared pool of information and observational data. You know, we do have laws, but there's no ownership. There's no real estate deeds. However, first come, first served, meaning once you're there, and it's difficult for other people to participate. There's a potential to make lots of money. So there's a new gold rush led by commercial space activities. Access to space is now cheaper and easier. So that makes the preponderance of launches increase. And we don't have any agreed upon norms of behavior of how to jointly manage that common resource. So there's no space traffic rules. Lots of space traffic, no space traffic rules. What could possibly go wrong? So we have this thing called space situational awareness, which is really decision-making knowledge for stuff in space. So we'll talk a little bit about that. So on the far left, we have a space environment, and it has effects and impacts on how operational objects, you know, how they behave. And not only that, but also the space environment, just like currents in the ocean move, you know, are part of the input to how ships move on the seas. The currents in space also are responsible for how things move. So we have to understand that better. We don't understand that well enough. And then there's never been a domain of human activity that has been absent malicious behavior. So humans aren't all benevolent. And so, you know, in a domain that's very unmonitored, where there's a lot to be gained or lost, you better believe that humans, there's some subset of humans that are going to behave badly towards others. And so we need to understand what these threats are and monitor for that. What we need from space situational awareness is, in order for space to become safer, more secure, and more sustainable, we really need to make space more transparent. In other words, what's up there? Who does it belong to? What could it do? More predictable. Where are things going to be in several hours or several days or several weeks? And in any given situation, what are two different entities going to do? How will they behave? Which part of that is cultural competency. And then can we develop a body of evidence that can be used to hold people accountable for their behaviors in space? So we have a few challenges. one of the things that we use is this thing called the OODA loop, which this gentleman, John Boyd, in like 1980s put forth. And it really stands for observe, orient, decide, and act. And in data science analytics, you have a similar kind of structure. But basically, you have a set of observations or opinions about stuff in space. These need to be mapped into a framework where these can be understood, a lingua franca, if you will, something hopefully that's properly modeled information, curated information, that sort of thing. So then that way, different users can query this set of knowledge that can underwrite very critical decisions related to safety, or like maybe I need to move my object out of the way to avoid the sort of collisions that I described earlier. For sustainability, decisions might mean understanding the space traffic footprint of objects and the carrying capacity of a given orbit, and at what point am I saturating that capacity. And things from a space security perspective might be before I come close to this other object from this other country, maybe I can notify them some way so that they don't think that I'm up to something malicious, so that I'm very transparent and people can know what my intentions are, these sorts of things, which then lead to action. So this OODA loop is very important. And I would say that by and large, within the space domain, I think the orient part has been the thing that's been mostly missing, and it's not easy to get to the decisions. So astrodynamics is the science that studies motion of objects in space. So Astrodynamics 101 here is that you have some satellite, it's going to experience some sort of acceleration due to the fact that Earth is beneath it, kind of thing. And the moon and the sun also exert some influence on its behavior in space-time. You're going to have photons from the sun interacting with different surfaces, heating these things up. These things are going to absorb some energy and re-emit those thermally. Earth also reflects energy and emits thermal energy, and antenna power also can produce accelerations experienced by these objects. We have tidal effects, and then there's this guy, Albert Einstein, came up with this cool theory called relativity, and again, back to this idea of space-time being a fabric where these objects are located and move. So space environment effects and impacts. The space environment can cause disruptions. It can cause a loss of power and other types of electronics on board. So it's a harsh environment that we somewhat understand, but not completely. When satellites experience anomalies, we need to be able to know, was that, the causal relationship between the anomaly and was that due to something natural, or was it due to something human-made? The decisions that you make are going to be very different depending on what you believe that cause to be. Unfortunately, in our field, we suffer from confirmation bias, or what I call belief inertia, where once we believe something, we have the tendency to reject any information that is contrary to our belief, and this is very dangerous. And so as we move forward, we need to be able to consider evidence and allow the evidence to change our beliefs if the evidence is really pointing us in that direction. So we need to be very cognizant and very aware of this. When we have incomplete knowledge, when we have incomplete information, we can make the wrong decisions. And so, part of the reason to aggregate disparate sources of information is to get a better and a more holistic picture of what's going on so that our decisions can be more informed. Case in point, if, and I'll show you Astrograph again, kind of live, but if you try to see what the, US Department of Defense's opinion is of things in space, you might see something like this. But if you wanted to see the Russian opinion, you might see something like that. Those things don't look the same. So that is of concern. And even for a common object, you might have 4 different opinions of where that object is located. And that makes a difference for trying to understand hazards in terms of collisions and these sorts of things. So we need a way to achieve consensus amongst different opinions and sources of information. We ultimately want to understand this population of anthropogenic space objects. And so usually if you try to understand a population, you identify individuals in this population, you tag those individuals, maybe with some location device that's based on GPS, formulate some hypotheses, track the behavior of those individuals over time and space, test the hypotheses, identify correlations, and then hopefully infer or determine causal relationships. This works well for things on the Earth that you can go up to, but for most of the stuff in space, we can't do that. So we have to do something equivalent of this tagging and tracking via remote sensing. Detecting and tracking things is not the same thing. This is a set of detections from a sensor called the Space Surveillance Network, and this is a single night's worth of detections. All the detections in black are things that we believe we know the identity of, and everything else is unknown. So detecting is insufficient. We want to track things, and tracking is detecting and identifying. I told you that, we track about 26,000 things, only about 3,000 work, everything else is garbage. And most of the things up there in space do not self-report their identity because they're dead, it's garbage. And so another way to say this is, if we collect detections over different times and at different places in space, how do we solve the identity crisis to figure out which object is which in that pool of data? That's a challenge. I tell my students, if you want to know something, you have to measure it. If you want to understand something, you have to predict it. Measuring is the foundation. So if you start on the left with things that we can measure, question is, what combination of things that we can measure lead to insight of physical characteristics of these anthropogenic space objects? And then which combination of those physical characteristics gives us insight into functional and operational properties? And then further to the right, can we come up with a taxonomy or a classification scheme for these objects? We make use of knowledge graph databases. We have schema or ontologies that help us have a semantic description of different elements in the domain. And this helps facilitate linking disparate sources of information. The way Astrograph works, if you look on the far right, in the upper right, is we have a 3-layered system. We have multiple sources of information that we call instance data that come into the Texas Advanced Computing Center on the ground floor. We have interpreters that know which part of the information is relevant to what it is that we want to build in terms of a digital library of things in space. That digital library, for all intents and purposes, is the mezzanine, the middle layer, which is Astrograph, which is the knowledge graph database in Neo4j. And then we can expose that curated and modeled information to different applications that can run a variety of analyses like classification and clustering and feature extraction and these sorts of things. So this is the way that the framework is structured. We focus on abductive inference. We try to go beyond correlations to discover causal relationships. We try to basically enumerate various hypotheses and only reject the null hypothesis if the evidence makes it look ridiculous or crazy. We try to avoid assuming past the information that we have in hand. We try to be allergic to confirmation bias or this belief inertia that I spoke about earlier. We like using observations to remove ignorance. And we understand that uncertainty can be aleatory or random or epistemic or systematic. And, we gain confidence by being able to independently corroborate evidence. And we are strong believers in multi-source information because of all these reasons. So what are some examples? Very different user needs given a common pool of information, this digital library that we've put together. One example is from the astronomy community. They have a need for dark skies because they're trying to collect photons from very distant natural phenomena, galaxies, nebula, these sorts of things. And unfortunately, the anthropogenic objects that we have in Earth orbit reflect sunlight down to Earth. And so these things can become nuisance objects or clutter to the astronomy community. So we've been asked, could we put together some sort of modeling and simulation to demonstrate this? So what I'm going to show you is a video of, from an astronomer's perspective with cameras that integrate signal over some time. What you're going to see is here is if you were standing at this telescope in Chile, looking straight above you is in the middle, and then north, south, east, and west. And all the streaks are human-made objects, anthropogenic space objects from the 26,000 objects that I told you about that are reflecting sunlight in visual magnitude. What you're going to see in this part is this is a celestial sphere, a unit sphere around the Earth, and showing you the direction in which the telescope is pointed. And then this is basically the line of sight from the telescope to the sky and locally if you were at the telescope. And all of these regions in gray are below the horizon. So the telescope is not capable of seeing this region of the sky. But here you're going to see from dusk all the way to dawn. And all these objects are things that humans put in space that are reflecting sunlight in the direction, what the telescope could see. You see these things kind of disappearing a bit, not because the objects are disappearing, but a lot of these objects are going through Earth's shadow or they're being eclipsed. And so in the middle of the night, you can imagine that at midnight, that's when you get this minimum reflection. And then as sunrise is happening, the sunlight again is reflecting sunlight off of these objects. So this is what astronomers have to deal with every day, to just go through this to get the signal from nebula and other things important to astronomy. So that's an issue. Another user might want to know, who's compliant and who isn't with different laws, policies in space. And so this is a very interesting and very critical question that's asked. You can't enforce things that you can't measure, back to what I said before. And so we put a use case together to monitor for compliance for how people dispose of their satellites in this region called GEO at the end of their life. This just gives you an example of the schema that we put together in Astrograph to make that happen. And this is just like the website where you can go and see these demos. And I'll leave these these slides, this presentation, this is being recorded, so you can go there at your leisure. Another user is interested in being able to fingerprint objects. Can we use biometrically inspired techniques to uniquely recognize objects? So in biometrics, you tend to have a three-layered process where you have enrollment, verification, and identification. Can we use remote sensing and do the same thing with anthropogenic space objects and take advantage of the fact that, again, they're reflecting sunlight, so photons are interacting with the satellite and being measured. So we have a photon counter that does that. Here's an example from a satellite roughly at 800 kilometers altitude called Topex. It's a dead satellite, so it's just tumbling. And so what you see here is this is an artist rendition of Topex. On this axis, we collected data for about 11 minutes. The brightness is the amount of photons reflected from the object. And then as the object is tumbling, going once around its body, you can kind of see the reflections, reflected sunlight that we're getting from that object. And we're just exploiting specular and diffuse reflectivity of that object, okay? So what we do is we say, okay, once we have these reflected photons, the first thing that we do is try to infer the inertial to body orientation of the satellite. Once we believe we have that, then we can freeze the body frame. And in the body frame, we assume a unit sphere. We build a heat map of reflected photons on that sphere. And then we can represent that in a two-dimensional projection called mulvide. And so this now becomes the fingerprint for that given anthropogenic space object. We call it a quanta photogram, a QPM. And so here you can see this is the signal that we get, and by applying this process, here's the fingerprint that we're getting for Topex, and this is real data. This is the front of Topex, here's the side, and this is the back. So we can see different features of reflected photons from this object, and all the parts that you don't see filled are parts of the satellite that we were not able to observe. So one question is, are there persistent features from one night to the next? And the answer is yes. These things don't look identical, but you can see that there's some salient features that persist from independent observations. And so we believe that we have a method that could actually be used in this biometric sense for recognition. So with that said, I just want to kind of close off with, Rudolf Emil Kalman, one of the co-inventors of the Kalman filter at the Kyoto Prize that he got in the 1960s, said, whenever a model is built, it's always proper to ponder the basic scientific question, is the model really based on the data, or is an artifact displaying the prejudices of its creator? And this is back to the confirmation bias. We want to try to understand things without making any sort of assumptions that could prejudice the outcome of what it is that we're trying to infer. And so I'm going to try to stop this here, and before I actually get questions, what I want to do is I want to do a new share, and I want to do a new share of probably this opera thing. And let's see if I can, escape. Let me just stop sharing here so I can see if I can do an escape of this. And can people still hear me?
Yeah, we hear you.
Okay, hold on a second. Let's
no problem. Take your time. Yeah. Very interesting, because this is so important for the future. That's why I'm very happy that you accepted to talk about this to a public maybe who is not aware about the things. So yeah. I'd like to continue your presentation.
Yeah, so basically here's Astrograph, and this is showing you the current state of opinions about stuff in space with all the different opinions from different sources. And again, like I said, if you go to the Department of Defense's opinion about stuff in space, and I'm just going to include debris and rocket bodies there, so you can kind of see the full kind of catalog or database of stuff that available to the public. This is kind of what you're going to see. But if you again ask, what do the Russians think, then that's their picture. And so these things don't quite look like each other, and so that's an issue. This is the reason why we want to crowdsource. We want to crowdsource all these things because we want to get the best idea, the best picture, for lack of a better term, of what's in space. And again, the dots are not to scale, but this just gives you an idea of some of that traffic. This line that you see here is one of the Starlink set of Starlink satellites up there, and you can go to this and you can kind of click on anything and get an idea of the orbit the thing is in, and you'll get some notional parameters of that here as well. But anyway, this is something that people can explore kind of at their leisure. So with that, I'm going to go ahead and just stop it there.
Thank you very much, Dr. Moriba Jah. And it was very, very informative. And so if someone has a question, I can start. So first, is it too late? It's not too late. I mean, for what I see, actually, just the picture, even on your site, etc., it's not too late to say that we can do something about what is. We don't. Can we do something which could be useful? Because for me, it seems too late in terms of action. Because how we can get back this garbage? How? There is no tech actually who can pretend be safe and do what is necessary to clean the space.
Yeah, I mean, my opinion is this. I don't think it's too late. I think that what we want to do is we want to educate the public, let them know about this environmental problem that we have with space, extend environmental protection narratives to include space, so oceans, atmosphere, climate, and space. But I think that, you know, AR, VR has a critical role to play in the education of the masses with respect to this environmental problem, and when it comes to facilitating decision-making for owners and operators and regulators and policy people as well.
I have a question. I mean, it's very impressive. I've never seen any visual like this before. I mean, you read about data, but then again, you know, somebody tells you there's 1,500 satellites in the orbit, and you just don't. It you know just doesn't reaches you. But now it's visualized. It has impact, and I don't think I've ever seen anywhere anything like this. I mean, I'm kind of following these areas as well, and this is super impressive. But now there is many companies trying to launch, and they are in business launching satellites, doing them. But is there eventually any initiative, or are there any companies privately that develop technologies to safely take down space garbage out of the orbit and, let's say, back down to Earth for disposal?
Yeah, so so the answer is yes. You know, Astroscale from out of Japan is one of those companies. There are several others out there. The European Space Agency has this mission Clear Space, which will, you know, out of EPFL in Lausanne, is going to go and grab this Vespa payload adapter in 2025 to demonstrate technology. So yeah, so people, there are private companies, there are governments looking into this as well. I would say this, the best way to think of this right now is probably with the COVID pandemic and looking at kind of the spread of the pandemic, much like the spread of debris of these anthropogenic space objects. We're just creating all this stuff. And so if we want to flatten the curve, on the debris generation and spreading, the first thing that we have to do is incentivize people to comply with the guidelines and regulations that are already out there. So the thing is, most experts will agree that the biggest issue in the creation and spreading of the debris in space is a lack of compliance with these guidelines and regulations, which goes back to the need for monitoring and assessment to put the evidence out there of these behaviors. So flattening the curve, the best way to do that would be to incentivize compliance. And then the next thing is, we want to, just like we want to avoid super spreader events with COVID, we want to avoid super spreader events for debris in space. And what that means is that, you know, large rocket bodies that are still up there from many, many decades ago, these things are like time bombs. If anything collides with one of these rocket bodies, it tends to create a lot of debris. So that's a super spreader event when it comes to debris generation. So we could right now say these are the top 50 rocket bodies owned by US, China, Russia that need to be removed to avoid, because that's just a matter of when, not if. Like these things will end up blowing up, and they will be generating debris. So the world should move in that direction.
Wow. Right, right. So this that you showed us today is not really a public domain. I mean, in everyday life, we can go surf and look at these three-dimensional visualizations
Yeah,
you
yeah.
presented.
So what I'm gonna do, here is just right now in the chat, I'm gonna just give you this. I'm just gonna give you the website here, and yeah, it's just bit.ly /Astrograph. If you just go there, it gets updated
Right.
every day.
Wow. It's mind-blowing. Wow.
And what, sorry, recently there were this dangerous situation in space. Actually, in this case, who will be the police?
Yeah, so here's the thing, right? I mean, I think that so there is no global governance aside from like the UN, and the UN isn't really gonna police, but there's no real global governance for this. So that needs to change, but it's very difficult to get to that if you don't even know what's going on. So this is why I've been focusing on the measuring, the monitoring, the assessment, so that there can be evidence out there to humanity, and then I think it'll start making sense of how we start regulating this stuff.
Okay, and who can we say who is the biggest polluer? Who pollutes the most the space? Is it US? Is it China? Is it?
It's basically US, China, and Russia.
But the India satellites with the blow in the space, it brought a lot of debris.
Yeah, I mean,
more than
yeah. So I mean, India. By the way, I just want to share this project, Eyes on the Sky. Yeah. So people can go there, and the interesting thing is that we are planning with Eyes on the Sky and using this kind of Sky Dome mixed reality sort of experience. So I definitely would encourage people to visit eyesonthesky.org to check it out and be a part of this. But yeah, so the thing is, India created a lot of stuff, but if we look to the history from Sputnik all the way now, the three dominant contributors are the US, China, and Russia.
Yeah, absolutely. Okay, and can you explain a little bit, maybe for the few attendees we have, and sorry for that. I think there is miscommunication, but the Kessler effect is something that makes me nervous, the Kessler effect. Can you explain a little bit what it is, and if there is a risk that we leave it in our life?
Yeah, so I tend to dislike talking about the Kessler effect, and what I prefer to talk about is carrying capacity. And so every ecosystem has a carrying capacity above which, at least for living organisms, you have pandemics, sickness, these sorts of things, right? Because the environment can only tolerate so much use by the population. So there's ecological carrying capacity. There's also carrying capacity of highways. Highways can only take so much traffic safely, and then there's going to be some threshold above which lots of accidents and bad things happen. So I think similar to that, we need to globally embrace the idea of orbital carrying capacity, define that, and we can think of the orbital carrying capacity as if if there's a time when our decisions and actions can no longer prevent collisions and these things from happening, then the carrying capacity has been exceeded. And so we want to quantify that carrying capacity, use that within regulatory frameworks for licensing and these sorts of things, manage that capacity globally. And we want to avoid anything possible that could saturate or make that capacity get exceeded, because at that point we wouldn't be able to use that orbit effectively anymore.
Okay, I can understand. So it's a more positive way to show the thing than being stressing people with.
Yeah.
It's a good way. Yeah, I think maybe because there are so many things to be afraid of this time. So you're right. I'm absolutely right about that. And about this private company, you talk about SpaceX, but you also have Jeff Bezos satellites.
Yeah, with Amazon, right? With Project
Exactly.
Kuiper. Yeah.
Recently, the British were planning to send also a kind of constellation of
OneWeb.
etc., etc. And what is difficult for me is really to understand who gave this authorization to launch it. I can't understand.
So this is the thing, man, is each country has the right to launch whatever it is that it wants, based on the Outer Space Treaty and other of these kind of legal instruments. And so people just say, listen, you just have to make sure that you're not interfering with other people. So there's all these kind of things, language in Outer Space Treaty and these other legal instruments that talks about peaceful uses and all this other stuff. But as long as you interpret that in this way, you can launch whatever it is that you want. So again, the thing that I try to underscore, right, is saying we should define this carrying capacity, and the carrying capacity doesn't belong to any specific country. It belongs to humanity. And once we understand this carrying capacity of orbit, let's put together a framework of global governance where we can jointly manage that carrying capacity. And if we license Acme Incorporated to go into space, then we as a global society are basically saying to Acme Incorporated, you have this amount of the capacity leased to you over N years, and the intent is for you to give that capacity back or renew or some sort of thing. But we have to do this, I think, in terms of managing the orbital carrying capacity. And as long as we don't have that defined and accepted, then I think we're going to continue to see these things where people are just going to start launching 10,000 things. And so we're headed toward a tragedy of the commons, in my opinion, for sure.